Hey everybody, this is Larry, this is Miko for Q4 of the weekly contest 351 Robot Collusions. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this poem. So this one I feel a little bit sad about, to be honest, because I took 24 minutes and 2 wrong answers on this one, though I don't think it shows up anymore. Though, I mean, the 2 wrong answers were silly, copy and paste typos that I did twice, so I don't feel that bad about that part, but I was a little bit slow, even though I knew what to do with this one. I'm going to put up drawing really quick, but so hang on. So yeah, so basically, I think the visualization is the key part for... Oh, why is it over my face? Is it always over my face? I pressed something by accident. Okay, there we go. Maybe a little bit. Okay, good enough, I guess. Yeah. So basically, the key part about this is the visualization, right? So you can think about robots in a line, but also over time, I think is another way of thinking about it. Meaning that, okay, I think this is a concept that comes up with respect to, in physics, with respect to, you know, light cones and stuff like this. That's the way that I think about it. You don't have to think about it necessarily that way, but maybe this will help anyway. But basically now, instead of a one-dimensional thing, you can think about the 2 dimensions, right? So let's think about, you know, let's say, you know, this is the x-axis, and instead of the y-axis, you have to... Did I mess this up? No, this is the t-axis. Yeah, it should be right. Unless I messed it up. Is it x over t or t over x? Huh, give me a second. Man, there's... No, this should be right? So this is plus t, right? So that means time goes on. That means that if there's a robot, you know, we can model a robot at t is equal to 0 is the initial position. And we can model a robot. Let me change the colors real quick. Let's say going to the right. You know, let's say it started here. Then as time goes on, it goes this way, and they all move at the same speed, so they all have the same slope, right? So you have, you know, robots that are like this, and then you have green robots that are like this, right? Going left, say, over time. So yeah, so that's step 1. And, you know, once you have this visualization, you notice that, you know, the robots facing right or going to the right are only going to interact with robots facing left and vice versa, right? So that means that all the robots facing the same direction, they never interact with each other. So that's an observation as well. So basically, the idea here then is, I think with this visualization, maybe it's a little bit easier to see, but with this visualization, then now you could see that we're trying to resolve this from the bottom up, right? That means that we're trying to find this point, and then maybe, you know, process this point, and then this point, and then this point, maybe, right? If the robots are not, robots still have health. Okay, so what happens here, right? You know, but given let me change the color again. You know, given L robots facing left, or maybe the other way. Yeah, L robots and R robots. You know, there are going to be L times R intersections, right? I mean, I think this is very basic. I'm not going to go over why. Hopefully, this makes sense. There are just that many intersections, you know, between these lines, right? And I think that's how they teach multiplication these days, or something in some curriculum. I could be wrong. Anyway, so yeah. And of course, given that n is equal to 10 to the 5th, let's say half of them are on L and half of them are on R, that's roughly speaking 10 to the 10 over 4 or something like this, right? Which is too big. It's like 2.5 billion. So that means that it's going to be too slow. It's going to want time limit exceeded. So the naive way after this visualization would have been to plot all the intersections and then sort them and so forth, right, by t and stuff like this. so here we use one more observation, is that given a certain line, let's say this one, right? Oops, how did that happen? Let's say this one. Well, the first thing that it is going to connect to is going to be here, right? So basically, and then this one, and then so forth, right? So basically for each one facing in one direction, you just have to go to this one, and then now you scan, and then you go to the next one, and so forth. So basically, and these will correspond to these in that order, right? So that is a shorthand, and that means that we can, instead of putting everything and then sorting it, we can put it in a heap object, get the minimum, get the closest one, and then when we process it, we get the next one after that. And because of that, there will always be L plus R or something like, or technically minimum of, either minimum or maximum of L and R. So maybe let's just say O of L plus R, number of things in the heap, which is going to be fast enough because each operation is log n. So, and the n things in the heap, because that's what L plus R is. So that's going to be n log n in terms of complexity. So that's going to be good enough. So that's basically the idea, the core part about this problem. After that, it just becomes what I call bookkeeping, right? And when I say bookkeeping, is not a type of algorithm. It's just keeping track of where everything is and making sure everything is consistent is what I call bookkeeping. So let's go over the code. Hopefully with that visualization, you can do a simulation very quickly. I wrote out too much code, to be honest, so I'm not happy about this. There's a lot of repeating code, which is how I got 2 wrong answers instead of 1 wrong answer, and even the first wrong answer was due to a typo. So, but yeah. Yeah, let's go over it. So basically, I put the left and the right on a sorted list. This is just so that we can this is so that we can very quickly sort through the things that are alive on the other, that are facing the direction that you want. We'll go over, I mean, we'll see how that works in a second, but that's basically the idea, right? So if it's facing right, I think I kind of mixed up with the terminology, so that's why I got confused, but I think here I meant facing left from the right side, or something like, yeah, if it's going to the right, it's on the left side. If it's going to the left, it's on the right side. So that's why it looks a little bit awkward, but yeah. And then now after that, we sort the events, right? We set up the events to begin with. And the initial event, we just get the next, if you look at the visualization, just remember it, we just looked at the next one on the left side. And here, because of symmetry reasons, we only have to care about one of them, right? Initial, meaning that, on the, which way did I do? Yeah, basically for here, I looked at the stuff that's going to the right side because it's by symmetry, if the two things that are closest to each other and you want them to be facing the same or facing toward each other, that's going to be the same. So that's why I did it only on one of them. Yeah, and here basically for every robot that's facing or going to the right, we look at, that means that we are using the left side, but basically on the right side, we calculate the closest one by using a binary search on the right side. Basically, this is all the robots facing left, or going left, and we do a binary search. And yeah, and because all the positions are unique, I don't have to worry about bisect left or bisect right. So it's a little bit sloppy, but but that's the reason why. And then if this is found, the opposite being that if it is way off, then there's no, it's not matching anything, then don't worry about it. Yeah, so if you think about them as, if you think about each robot moving, because they're all moving at the same speed, I think this is the part I missed, if they're all moving the same speed, then the intersection is going to actually be the distance between them over 2, right? Meaning that if they're 10 units away, they're going to meet in 5 units, right? Or 5 time units. If they're 20 distance away, they're going to meet in 10 units. If they're 9 units away, they'll meet in 4.5 seconds, right? So that's basically why I did this, so that I do the delta on the distance, and then I use that as the key, because so the distance is directly equal to over 2, say, the time it takes to go to that place. So that's why the delta is thing. And then here I keep track of left and right. And again, these 2 things are indexes, right? The robot indexes. So they'll always be unique in the thing, because if all the positions are distinct. Well, okay, so actually they're not always unique, but which is why we have things later. But yeah, they're not unique in the sense that, just to be clear, they're not unique in the sense that you can have like L, L, and then like a R here. Oops, that's a Y. R here. Of course, this left matches with this R, and this left matches with this R, but you know, we'll resolve that later, right? That's what the heap is supposed to do. And of course, after we append everything, we heapify it so that we get the min on top, min delta, and that's basically the how we use time. And it really doesn't matter after that. Basically, now we get the left index and the right index. We pop it off the events. If they're both already dead, we just kind of skip it. If only one of them is dead, so basically if the one facing left is dead, so that means the right one, which is the terminology is very confusing, but basically you kind of find, so you find this so that you could so that you find the partner, because basically this is saying that, okay, one of them is dead, so then now you have to enqueue the next one, which is the one after that, for the one that survives. So that's why we look at the position of the right index, and then we kind of try to find it in the left, and then we heap that with the new delta and so forth. Also, this is exactly the same thing, but for the other direction. Otherwise, we just simulate it, right? And then we also skip. Otherwise, we simulate it, and this is basically the same as they tell you, which is that, you know, if one of them is bigger than the other, you kind of just subtract 1 health, set it to 0, and we remove it because it's dead, so that we don't binary search on it anymore. And then we binary search for the next thing that it could match, and then delta. You can kind of visualize this as well by drawing it to yourself. But yeah. And here is the same thing, except for the bisect left, we run the next one before that. So that's why we have this like -1 check and stuff. And basically my typo is that this was 0 for some reason. And I copied and pasted. So it happened in 2 places for 2 wrong answers. So yeah. Otherwise, they're both dead, and they both get removed from left and right. And then at the end, we filter out all the zeros, and that's it. Yeah. So what is the complexity, right? Heapify is linear, but how many events are there? There are at most n events for whatever reason, like L plus R, right? There's only 1 event. I mean, technically n over 2, so, but still all of n number of events, and each of them does a pop on n events, so that's going to be n log n, and we have a lot of logarithmic type things. We have a binary search here, we have a heap here, binary search here, heap here, binary search here, and a heap here. So a lot of log things, but everything is log, so that's going to be like constant number of log things. So this is going to be n log n. And there you go, that's our n log n algorithm. Show you the top, and let me show you this ugly chunk, and then the bottom. And that's all I have for this one. Let me know what you think, and you could watch me solve it live in the contest now. Come on, baby. All right. Not having a good contest. That was such a sloppy thing. Too. All right. N1 indexed robot. Why do you have 1 index robot and 0 index everything else? What does that even mean? Why? Who did this? Who wrote this? Who heard you? Anyway, okay. You have robots on the line. Okay, let me actually read the prompt. You have robots on the line. Directions left, right, positions, and healths. They'll collide. They collide. The lower health is removed from the line. I mean, it seems like this simulation, right? They all move at the same speed. Alright, so 10 to the 5th. Can we, what can we do? So for each one, we can look at the next thing that it is. Thing, right? And then have a event. Because only the relative positions matter. So then the delta is the big thing, right? Alright, how do I want to model this? I mean, it's just simulation. I just have to figure out how to model. So you have the events. And every time something crashes, I mean, there's only at most n events, and you just keep on like a heap, right? Or sorted list if you want to be inclined. And the relative position is always the same, right? Because if they collide, then there'll always be more collision. So at the end, they all face the same direction. Right, so okay. So we want a heap. I don't know why, but positions are distinct but not sorted. Wait. In order they were given in the input, not the positions. I mean, that's just more tracking, but I mean, that's fine. It's just more implementation silliness. Okay. Next, I guess health doesn't really matter. We want directions and enumerate. Haven't done this in a while. D is equal to L, then X index. Something like this, right? you have events. Oh, that's the heap, I suppose. Yeah. I actually don't know whether that's. So from left, we want the basically, right? If I think we can just go straight from the left too, but then it's a little bit. I don't know the cost of enumerating through a sorted list, to be honest. So I don't want to add an extra constant. Okay, so then right that bisect left and bisect right doesn't matter because it should be unique anyway. Positions of I. Also, the index doesn't matter for that reason. Okay. If right, then right of index. Left will be looking at the right, so I mean it should be that way, but I'm just gonna be lazy. I guess I could just heapify everything later. Delta is the big one, and then index. Is index enough? Yeah, I guess so. Yeah, it should be okay. Now we want this, but we want this instead. Okay, and then now heapify. Just wanting it to see if I wanted anything weird. Alright, looks okay. Didn't give me any error. So while length of events is greater than 0, what do? We have the delta, which we do not care for. And the index of the thing. This index is wrong. What we want is I. Yeah, whoops. We do care about index here because we need to track it. Right. And then now that the index, we have to do this bifurcation again. Let's go I. Whoops. Oh no, this is delta. That's why I don't care for it. If this is left, then we have to find the right thing again, and we just get just make this I. And technically, maybe this the different one, right? Wait, what am I doing? Yeah, why don't I just do this index and then now index I, right? I think in fact, because of symmetry, we don't even need this part. Yeah, okay. So then now we have delta, left index, right index. But this index is in this index. This should be right index of 1, the original index. And then now we can process it, which is that if health sublin index, if this is equal to 0, we continue, I think. That means that they're already dead and we somehow in processing this. Otherwise, if health sublin index is greater than bar index, then we kill the right side. So remember to remove Larry. So R index, but the X is going to be precision sub R index. And then subtract from 1. We just need the final health, right? And so this should actually be right, except for we'll just filter out the zeros, in theory. Oh, I'm skipping a step. That's why things are kind of confusing. But let me finish doing this thing first. Okay, because we have to, after this, we have to add more events. Let's actually see what happens. Seems like nothing happened. Well, the first one's right, I guess, because nothing happened. But let's actually check this out. I don't even know which input this is for, so that's not really helpful. Oh, so this is for last one. Index 1 and 2 collide, which makes sense, maybe? I don't even know which one this, oh, this is X and the Y. Oh yeah, that makes sense. And then this dies. Okay. I think this makes sense so far because we don't have any iteration. But then basically when left wins, we have to find another target for it. So yeah, so F wins, then do another binary search, and then okay. If the right wins, that's when we have to do the thing. I guess I shouldn't have deleted that part. Oh no, I cannot append anymore, but I'll fix it. I think that this is wrong. So the left index 1, so left index is the same. The right index we updated to this thing, which actually is right. Okay, fine. Now the right index 1, so then we have to update the left index, which is this thing, and that's fine. But it's not a pen anymore. This is now Okay, fine. Consistent. Alright, that's unfortunate that didn't do enough. I was hoping seeing more zeros here. Let's see. 1 and 2, but it doesn't. That's it? So the right side wins. Should be here. Oh, it should be here rather. Okay, so you have 6 and 3. Wait, what is my answer on this one? Oh, I mixed up, didn't I? Because basically for the left, yeah, I mixed it up. Okay, but I could fix that easily. Just have to. I mixed up the confusion, I think. Okay. Because okay, there you go. Well, maybe still not right, but at least this one is right, and this one should be right because it doesn't do anything. But this one's wrong. 0, 0, 15, 12. Why? This example, 1 and 2 will collide. They're both removed. Oh, I didn't remove them from here. Oh, yeah, I do. Huh. I think I'm close, but I'm really slow. Okay, so 0, 1, and then 2, 1. That's right. No. 2, 1 is wrong. Oh, I see, because I just skipped it with continue. What I need is that, given that this is dead, I need to re-queue the other one. Okay, fine. Okay, if they're both dead, then we can continue, I guess. But otherwise, and the other one's alive, then we have to re-queue the closest one for right. So it's as if the right one. So then basically it's this part. Too much copy and paste. And then if house of right index, then it's this part. Five one on the list. Okay, fine. Why? What you talking about? Why is this I? What is this I coming from? That's why. Wow, that is a pretty bad typo though, actually. And I still didn't catch it until now, and this one here too. Still not on the list, huh? What line is that? 460 to 48. Why would it get removed if... because if one of these, then we have to continue. We just have to requeue and continue. Okay, now it looks right. Put like this, like a dot photo, something like this, right? Maybe the other side. I don't remember how to do it, but okay, fine. I feel like there's a functional one for it, but okay, fine. And I'm still not done. I still have Q2, even if this is right, and I don't even know that this is right quite yet. Oh no. Wait, what? This shouldn't happen. Did I use the wrong thing? Alright, well, the algo is right, but my implementation again has something to be lacking. Gotta practice that a little bit more, I guess. Okay, left. Did I put in the wrong thing? Why would it index be 11? I mean, it's definitely not right. 11 is the position. Oh, whoops. Typo. Okay, fine. Cannot escape the typo. Alright, let's go. What is going on? Do I have another typo somewhere? I mean, I must have, right? And this is bugging me out. 18. What is 18? 18 is like one of the inputs. Left index, right index. Oh man, I copied and pasted the same typo. And got two wrong answers for the same thing. Okay, fine. Come on, please be right. I mean, there were a couple of silly. Oh, I'm not done yet. I forgot. Hey everybody, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest, this problem, and all these things in between. I'll see you soon. Stay good, stay healthy, to good mental health. Goodbye. Boo boo.